Hello everyone. In this video, we will be solving 57th problem of the Blind 75 series. The problem is longest palindromic substring. This is the question, guys. The problem statement is given a string S, return the longest palindromic substring in S. The question is quite straightforward. You will be given string S as an input and you need to return the longest palindromic substring in that given S. So let's see what is this palindromic substring. As you can see, the definition of palindromic is given over here. A string is palindromic if it reads the same forward and backward. So the given string will be palindromic. If I even reverse the string, if I get the same result, then the given string will be palindromic. So as you can see over here, this BAB is a palindromic substring because even if I reverse this string, I will get the same result, that is BAB. Similarly, here you can see this BB is a palindromic substring because even if I reverse this string, I will get the same result. So what will be the extreme naive way to solve this problem? So as you need to find the longest palindromic substring in the given string. So whenever there is a question of substring or subarray, you can always try every possible substring and every possible subarray and check if that substring or that subarray satisfies the given condition or not. So this is the extreme naive way to solve the question related to the substring and subarrays. So you can check for every possible substring in the given string that it is palindromic or not. So let's see how we can check if the given string is palindromic or not. So suppose I have this string. So you can see that this is a palindromic substring because even if I will reverse this string, I will get the same result, right? So let's see how we can check whether this given string is palindromic or not. So for checking the given string, I will take two pointers. We use two pointers approach to check whether the given string is palindromic or not. I will take two pointers I and j. I will at first I will put the I at the starting point of the given string and j at the last index of the given substring. Now what I will do, I will just compare these characters, the characters that will be at index I and j. So as you can see over here, the character at index I is A and the character at index j is again A. So if these two characters matches, I will just check next pair of characters. But if these two characters does not match, I can simply say that this substring is not going to be palindromic. So here we can see that the characters at index I and j are same. So we will check for next pair of characters. So what I will do, I will just move I in the forward direction and I will move j in the backward direction. Now I will check next pair of characters that are at index I and j. So we can see that at index 1 I have B and at index 6 I again have B. So these two characters matches. Now I will again check for next pair of characters. So I will just increase I ahead and j in the backward direction. So again I can see that these two characters at index I and j are same. So now I will check next pair of characters. So I will increase I and move j in the backward direction, and I can again see that the characters at index I and j are same. So at this point, after this point, I and j will cross. So for like till the time when I is less than equal to j, all the characters at index I and j are same. So I can say that this given string is a palindromic substring. So this is a general technique, the two-pointer technique to solve the to check whether the given string is palindromic or not. So we can use this technique to check whether the given string is palindromic or not, right? So if the length of the string is n, so you can just find you in the time complexity of n by 2, or we can say in the time complexity of big O of n, you can easily check whether the given string is palindromic or not. So like uh, if in you can generate all the substring in the given string using two nested loops, so it will take big O of n square, and for every substring that you generated, you can use this big O of n loop, this two pointer technique, to check whether it is a palindromic or not. So in the time complexity of big O of n cube, you can easily solve this problem. But can we optimize this? Let's see. So when I was checking for the substring, that started at 0 and ended at 7. So suppose I want to check, when I check for the substring that started at 0 and ended at 7, suppose if I want to check if this string is palindromic or not. So I checked the characters which were at index 0 and index 7, right? So I found out that the characters at index 0 and 7 are equal. So then I checked for next pair of characters. So when I was checking for this substring which started at 0 and ended at 7, I also checked for the substring which started at 1 and ended at 6, right? So like if I was checking for this substring which started at 0 and ended at 7, I also checked for this substring which started at 1 and ended at 6. I also checked for this substring which started at 2 and ended at 5, right? Guys, as you saw that when I was solving, when I was trying to find out the result for the subproblem in which the starting index was 0 and ending index was 7. So basically when I'm trying to check whether this substring that starts at 0 and ends at 7 is palindromic or not. So to determine this, I also checked for the substring in which the starting index was 1 and ending index was 7. I also checked for the string in which the starting index was 2 and ending index was 5, right? So, to determine whether this substring is palindromic or not, I also checked whether these two substrings are palindromic or not, right? So, as in my approach, I am just trying every possible substring and checking whether these substrings are palindromic or not. So, at some instance, I will also check this substring in which the starting index will be 1 and ending index will be 6. And at some instance I will also check whether this substring in which the starting index is 2 and ending index is 5 is palindromic or not, right? So I will, at that time I will again check for this sub problem that I have already solved, right? So I am just doing the repetitive task, and we can see that there are overlapping sub problems in these problems. So we can use the concept of memoization. What I can do is I can just store the result for all those sub problems for which I have already computed the value, so that I do not have to compute the result for these sub problems again and again. So I can just store the result for these sub problems in some DP array, so that whenever I encounter the same sub problems again, I just use the stored value in the DP array, and I do not have to compute it again and again. So let's write down the code for this and understand this approach more clearly. Okay, let's store the size of this given string in some variable. Now I will check for every possible substring in this given string, right? So for doing that, I will be using two nested loops. So this is the general template for generating all the possible substring in the given string. So you can always use this template to generate all the substrings. Now I need to check for every possible substring, right? I need to check whether this substring that starts at I and ends at j is palindromic or not. So for doing that, let's say I will call this check function, and I will pass these two uh, indexes I and j as the parameters, and I will pass this s. And let's say this check function will return me whether the substring that starts at I and ends at j is palindromic or not. So if this is palindromic, but I need to find the longest palindromic substring, right? So let's declare a variable max length. So this will store the maximum length, and as you can see over here that I need to return the exact substring, right? I do not have to return the length, but I have to return the exact longest palindromic substring. So I will store the starting point and length, because if I have the starting point and the length of the substring using the substr function in C++, I can just generate that particular substring. So let's say initially the starting point is 0. So this check function will return true, or it will return 1 if my substring that starts at I and ends at j is palindromic. So if it is palindromic, I will just check its length. So if I and j are the starting points, the length will be j minus I plus 1. So if this length is greater than the maximum length, so I will just store this substring. I will update the maximum length as j minus I plus 1, and starting point will be I, because I am considering this substring that starts at I and ends at j, right? So finally, what will I do? I will just return the substring s dot sub str. The starting point will be sp and the length will be max length. Now I need to write this check function. So this check function is basically to check whether the given string is palindromic or not. So we will be using the same two pointers technique that we just discussed. So it will return an integer value. So I will define a recursive function so that I can apply the memoization. So what will be the base case? As you saw over here, these I and j will be denoting the initially I will be at the starting point and j will be at the ending point, and I will just keep on moving I in the forward direction and j in the backward direction. So if at any instance I is equal to j or I crosses j, I can say that my given string will be palindromic, because if at any instance, uh, suppose at index 1 I have b, and suppose at index 6 I would have d instead of b. So at that point of time, this b and d would have not matched, and I would have simply stopped checking over here only, because now I can say if these two characters does not match, it means I do not need to check further these two strings. This particular substring will be not palindromic for sure, right? So if I and j reach at a common point or they cross each other, then I can say that the given string will be palindromic. So if I is greater than equal to j, I will return 1. Now I need to check this substring is palindromic or not, right? So I will say if s of I is equal to s of j. So if these two characters are same, now I need to check for next pair of characters, right? So I will say for checking next pair of characters, I will again call the same function. So I will say return check. I will move in the forward direction and j will move in the backward direction, and I will pass this string s, right? But if these two characters does not match, if I and j does not match, I do not have to check further, right? I can say that this string is not going to be palindromic. So I will just return false. Okay, so this is the plain recursive code for this problem. Let's try to run this. Okay, it is working fine. Now let's apply the memoization. So as you can see over here in this recursive function, the changing parameters are I and j. This string s is constant for all the function calls. So this s is not changing. The changing parameters are I and j. So I will create a DP array in which I will store the result for these states I and j, right? So the value of I can go from 0 to n minus 1, and j can go from 0 to n minus 1 again. So I will create a DP array of size n cross n, and I will just apply the memoization. So initially I will initialize this DP array as minus 1. This minus 1 represents that I have not computed the result for that particular subproblem. So if there will be any other value than minus 1, so it means I have computed the result for that subproblem. So I will just pass this DP array, and I will receive this as an argument. Okay, so let's apply the memoization. So I will say if I have already computed the result for this subproblem, I comma j, if it is not equal to minus 1, so it means I have already computed the result for this subproblem. I will just return the result. Otherwise, whenever I'm computing the result, I will just store the result in this DP array before returning. and I will pass this dp array in this function call also, right? Okay, now let's run this. Okay guys, sample test cases have passed. Let's try to submit this solution. And yes guys, it got accepted. Okay, now let's discuss the time and space complexity for this problem, for this approach, sorry. So here I'm using two nested loops for checking every possible substring in the given string. So time complexity for this will be big of n square. And inside this, I am just doing this check function to decide whether this given substring is palindromic or not. So it may seem like big O of n cube solution because for every possible substring I am calling this check function. But here I have applied the memoization. So basically here I am filling this DP table of n cross n. So to fill this DP table of size n cross n, the time complexity will be big O of n into n, because here this check for like for every sub in most of the sub problems, this check function will just return the value, return the stored value in the dp table. I will not have to compute like again and I will not have to solve, I will not have to find the answer for this whole sub problem again. I will not compute answer again, I will just store the returned value. So for filling this dp table, the time that I will require is big O of n square. And for every possible substring, for generating every possible substring, the time required is big O of n square. So the cumulative time complexity will be big O of n square plus big O of n square. So I can say the time complexity will be big O of n square. And the extra space that I'm using over here is this DP array of size n cross n. So space complexity will be again big O of n square. So in this way, you can solve this problem. That is all for today's video. Thank you so much.